Yep, we are live. Hi, Teck Chun.
Hello, hi.
How are you
Just
doing?
good. Thank you. Hi, those online. Can you see us? Welcome back.
Yeah. Thanks for
Okay.
joining us today. Yeah, and because it's Go Singapore, I brought this out of.
Ah,
Yeah, it's really cute. I think it was given out last year during the conference, right?
yeah. We miss
Yeah.
all the swags this year. Yeah, no swags.
Yeah, hopefully offline events will come back soon, and we're all looking forward to the swags. Yeah.
Okay.
Thanks everyone for tuning in and joining us today. Do make use of the live chat to ask questions and let us know where you're tuning in from. Before we begin, let me briefly introduce who we are and what we do. Google Developer Space is a platform for developers and startups from around the region to learn, connect, engage, and be inspired. As part of the developer relations team, we aim to empower and connect the community to our people, programs, network, and technologies, be it in person or online like today. For today's session, we are very excited to be hosting Go Singapore, led by Teck Chun. Thanks for bringing such a great line of speakers. And for our first speaker, we heard it's 4 a.m. from where he's dialing in from. So yeah, kudos to you and thank you so much for joining us today. Without further ado, I'll hand the stage over to Go Singapore to start today's session. Over to you, Teck Chun.
Thank you, Justin. Hello, golfers. Nice to meet you all again. Hope all is well. Time really flies. It's really August. In fact, end of August, and the year is almost gone. But we're doing this regularly. This is about the third or fourth installment of online meetups. So yeah, thanks to Google Dev Spaces for giving us a platform to do this. Today we have two speakers, and today's format is also slightly different from previous formats. So we do have a breakout room in between the two talks of 20 minutes. So we'll share the link in a while in the YouTube channel and also on the StreamYard. So feel free to choose any of the breakout rooms, 1 and 2. Like maybe you like odd numbers, you can go odd numbers, or you like even numbers, go even numbers. And the speakers will be one of them. We don't know where they will go. I'll be one of
It's a
the rooms.
surprise.
Yeah, the surprise. Stanley and the other co-organizer will be in one of the rooms, and we have another organizer, Ava, who is not able to make it today. But without further ado, let me first introduce, give a brief introduction to the two speakers. First speaker is Isaac. Isaac is based in San Francisco. So, like Justin was saying, it's 4 a.m. now. So thanks to him for giving this talk. He is the CEO and founder of R2C. It is a small startup working on giving security tools to developers, and it's based on Go. Right, really cool. His talk today will be on DIY Gosec, right? How to detect complex code patterns using semantic grep, right? And we have the second speaker, Suyin. Suyin is a regular speaker in our circuit. Many of you know him. He is one of the longest Go supporters of our community, and he frequently speaks and shares his knowledge. And today he'll be talking about consolidating policy and authorization decisions, like open policy agent using Go. Right? So a very interesting lineup of deep tech talks today. And without further ado, let me introduce Isaac to be the first speaker. Yeah, I forgot. Sorry, Isaac, just a moment more. We do have a few shout outs for today. We'll be doing a feedback form at the end of the session. And thanks to, we also have Golang licenses to give out for those who fill in the feedback form. That will be offline. We'll inform you when you strike the price. There'll be 5 licenses to give out. And we also share the links to one of the upcoming meetups for September. It is Go Southeast Asia. We are partnering Go meetups from around the region. We have this half a day Saturday afternoon session lasting about 3 hours. So see you guys there. Right. All right. Sorry. Back to Isaac. Yeah. Isaac, over to you. Thank you.
All right. Hey, everybody. My name is Isaac. Let's see. If I switch over. Oh, yep. That's my presentation. So yeah, I'm going to be talking today about a DIY Gosec, basically how you can detect complex code patterns in your code using a tool that I've been working on, which is open source, called semantic Grep. So let's get started. So a little bit about me. As mentioned, I'm one of the co-founders at R2C. We're a San Francisco-based static analysis startup, and our mission is to basically build tools for static analysis that developers are actually going to want to use, and will hopefully improve the security of the code that we all write. So the TLDR for this talk is basically that computers are really good at consistently applying human experience. And our thinking is that the future for security and tooling and automation is less about pointing out vulnerabilities and playing whack-a-mole with like, oh, here's a vulnerability, there's a vulnerability, and more about guiding developers into a paved road that's kind of known to be safe. So default safe frameworks, things like React if you are talking about the front end, or ORMs if you're talking about interactions with the database. And in order to like provide this paved road, we could use tools like Grep, but they're not really expressive enough to do what we want, whereas the traditional static analysis tools tend to be too complicated or too slow for enforcement. So what we want to have is a tool that is fast, easy to use, code-aware, hopefully multilingual, and ideally open source, and that's what we're going to be talking about. So that tool is SimGrep, which is designed to provide lightweight static analysis for many languages, and define bug variants with patterns that look very similar to source code. So in this talk, we'll talk about other approaches that you could use, so Grep and abstract syntax trees. We'll go over a tutorial and some examples, and then we'll talk about how to use SimGrep in a production flow, basically. So to start off with, here's a graphic that comes from a presentation by the Instagram engineering team talking about the sort of spectrum of tools that are available from a static analysis perspective. So on the right-hand side, you have whole program analysis, which they characterize as, hey, this is really powerful, but it's super complex. On the other end of the spectrum, you've essentially just got regular expressions, so the sort of things you would use Grep with. And these are easy to use, like very easy to write. They're pretty understandable. They're easy to edit, but ultimately they're pretty dumb. And then somewhere in the middle, you have things like AST-based linters. So you might be surprised that people would even consider using Grep and consider using it as a static analysis tool. A number of places, though, like if you're just looking for, hey, like does this code use the unsafe package in Go? If you grep the code for unsafe, you might have a lot of false positives, but you're pretty much guaranteed that like if somebody is using unsafe, you're still going to detect it. So a surprisingly large number of teams that I've talked to have actually gotten a decent amount of utility just from using Grep. But unfortunately, the problem with Grep is that ultimately it's not aware of the structure of the program. So it's easily confused by white space, by like import aliasing, by commented out code, things like that. And ultimately, this comes back to, yes, you can solve problems with Grep, but as XKCD says, if you had 99 problems and then you used regular expressions, now you have 100 problems. So maybe there's something that we can do that's a little better. And the fundamental issue is that, look, when we talk about finding code, code is not a string, it's ultimately a tree. The first thing that a compiler front end, and especially the Go compiler, is going to do is it's going to take an example like the one on the left, and it's going to parse it into a tree-like structure, as represented by the pseudocode here on the right. And so there are tons of tools that are allowing you to do AST matching in the Go space. GoLint, Gosec, static check is another one. Ultimately, like in order to do a good job at AST matching, you need to become an expert in the AST syntax for every language. So Go is actually somewhat unique in that there's an officially supported AST package, which provides an interface to you as the developer. But you need to learn the syntax of the Go AST. And then also, you need to be able to cover all of the idioms in the language. So if there's more than one way to do it in Go, you need to be able to write the AST matching code to handle each of the specific AST constructs. So here's an example from Gosec, actually the code on the right. We've got about 94 lines of code. You can see the sort of like how we're manipulating the AST.node types coming into this. And we're finding calls to like old or blacklisted cryptography functions in this example. It takes about 94 lines of code. It's not the most difficult thing in the world to write, but it's a significant effort if you're thinking about trying to get you or somebody else on your team spun up on interfacing with the Go AST. So if you wanted a commercial tool, there are commercial static analysis tools for security, especially. They tend to be pretty complex. They tend to be fairly slow and fairly expensive, and actually Go has really been an afterthought for a lot of those languages. I should mention for Go, there's specifically, it's not a multilingual tool, but there's a really cool tool called Go Grep, which if you haven't heard about, is similar to SimGrep, which is awesome. You should go check it out. So SimGrep tries to occupy a space in the middle where it's smarter than the AST-based lints, but it combines the sort of programming power of the whole program analysis with the simplicity of the regex-based approach. So I'll let you judge for yourself how successful we've been at that. But here's the TLDR. So it's supposed to be pretty lightweight and customizable. There are already hundreds of rules that have been written by folks in the community. So it's designed to be batteries included. It's designed to be pretty fast. It's designed to run offline on uncompiled code. And rather than having to learn some super complicated syntax, the patterns are actually going to be just Go code. So the intuition behind SimGrep is that you can grab a snippet of code and you can convert that into the AST, the tree representation, and then use it as a pattern matcher. And so now you have your target code that you're trying to search. You convert that into an AST. Now you just have a tree matching problem between the two. So let's see what that looks like. There are just 2 changes to the underlying source code grammar that SimGrep adds. So basically, if you know Go, you know how to write SimGrep patterns for Go already. I'm just going to show you 2 extensions that we've added that make it easier to specify certain things. So for this, actually, I'm going to be using a live editor that we have, which everything that I'm going to show you in the live editor, you can run offline. So if you locally install SimGrep, you can just pass what I'm putting here in the pattern box as a -e argument to SimGrep and then run it on the source code. Using the live editor is just kind of helpful to quickly illustrate and iterate. So if I wanted to find bad crypto calls, so RC4, run code 4 is a very, very old encryption algorithm that nobody really should be using anymore. Unless you have really good reasons because backwards compatibility or something like that. So what I can do is I can just copy code directly here from my test code into my SimGrep rule. And I'll say, hey, rc4.newCipher key. So this is valid Go code. It's also a valid SimGrep search pattern. And if I click run, it's going to find line 12 and line 15, which is pretty cool. So now I've actually, I can run this. It's got a little share URL here. I can run this locally on my code, which is kind of fun. If I click this drop-down button, I should just be able to pip install SimGrep, and then I can say SimGrep --config, pass it the short URL, and run it locally, or put it in CI integration, stuff like that. But you'll notice that we're not triggering right now on line 13 because here key has a different name. So we're just matching on the direct name of this variable here. And really, we would like to say, actually, hey, developer, really anytime you're instantiating an RC4 newCipher, I would like to trigger on this. So for this, there's an operator that we have, the first of 2. So the first operator is called the Ellipsis Operator. And so if we put a ... here, now we'll just match on 0 or more arguments of any type to this function. So if I run that, you should see that, yep, successfully we're triggering on line 13 here, which is pretty cool. And then if we were grepping, if we were writing a regular expression for this, we would also be triggering on line 20, but we're not, which is great. And then we would probably also, with our grep-based expression, we would be triggering on line 22. But because SimGrep is code aware, right, it's actually lifting into the AST representation, it's not triggering on either of those. So that's pretty neat. I guess I should maybe pause and see if there are any questions, or I'll just say, feel free to interrupt me if you have questions. I have the live stream open in another window, so I am looking at if anybody has questions that I can answer. Cool. So That's like a really basic example, probably like the easiest example we could imagine for finding banned functions. What about something that is more Go specific? So, like I talked earlier about, hey, if you have unsafe in your Go program, you're kind of opting out on a lot of the protections that you should be getting from, the Go runtime in terms of memory safety or things like that. So we might want to write a rule that's basically like, hey, like, is there really a good reason to be using this unsafe feature? Maybe we have a developer who's a junior developer who just like copy and pasted some code snippet off of Stack Overflow. And we just like to let them know, hey, like, yeah, actually, this is not really what I would like you to do. So here again, I'm gonna just copy and paste some code, unsafe.pointer. I'm gonna replace the arguments with this ... operator. I'm gonna run it. Looks good. We're triggering on line 18 and line 19 or line 20. But we also have there are a couple different functions underneath unsafe, right? So there's like unsafe.pointer, which we're using. There's also unsafe.sizeof, and in fact, there are more. So here's the second and final thing to learn about SymGrep. If I want to use a wildcard for the name of the function here, or actually a wildcard for any identifier in the program, I can use what we call a metavariable, but basically just like a variable that starts with a $sign and has all uppercase for the variable name. So here, I'm basically saying, hey, like any unsafe dot whatever, don't care, with 0 or more arguments, we should trigger on. So if we run this, we should see that we're now triggering twice on line 18, which is exactly what we hope for. And then the thing that's kind of cool is if I switch into the advanced mode here, this has actually like YAML behind the scenes. So like here is the YAML file. I've got an ID for my pattern. I've got the pattern itself. And I can put a message that says basically like, hi developer, please don't use anything from the unsafe package in our code base found. And then I can actually reuse the variable name that I used before. So I can have a message that's actually like highly specific. You can see over here, we're saying, hey, found pointer, found size of, found pointer to the developer. And we're going to come back and reuse that functionality later on when we start to write more complex patterns. But hopefully you're getting the picture now of, I see, okay, so we're parsing, like this pattern here, we're using the same parser that we're using on the Go code. And this makes it very, very easy to just rapidly prototype, oh, like I think this might make a good linter check. Let's run it on the code base. Let's do some iteration. Let's see how frequent or common this would actually be inside the code base. So now let's look at an example that is actually about configuration inside code. So not a function call or anything like that. In this example, we've got somebody creating a TLS client, and they have a specific config that they've set up for that client. So similarly, we're going to try to match on, hey, look, if somebody's setting the minimum version to be SSL 3.0, I don't know how much you know about the sort of like SSL TLS history, but SSL 3.0 is an earlier version of TLS, and basically it's not supported anymore by pretty much any browser because it had so many deep security problems. So in this example, I'm basically going to come through and I'm going to say tls.config, and then I'm going to use the ... operator to say, yeah, I don't care about what comes before this in the config, but anytime you have min version, I'll just copy this directly from the code, min version TLS 3.0, and then I don't care about what comes up after that in the config. I'm going to want to match on it. So that's pretty cool. Like here, again, like what's happening is that we're just parsing this into the AST form, and then we're converting it into a matcher that is automatically going to pull up line 15. The next question might be, okay, like what happens, what about other things? So like here, there's another flag, like maybe I don't just care about the min version. In this case, we're using version TLS 1.0, which is actually pretty much okay. But the developer has specified this flag that says insecure skip verify. So that's not great. This is basically going to say like, yeah, we don't care about actually checking the veracity of the server certificate. So you can actually create multiple patterns at the same time. So here I just press this plus button. behind the scenes, this is going to edit the YAML for me, and I'll show you what that looks like. But again, I'm just going to copy and paste my first pattern. I'm going to come back and grab insecure skip verify, and I'm just going to replace this section here. And if I click run, we should now trigger on line 26. So yep, even though min version is set correctly here, the second clause inside this is triggering for us successfully. And if I switch over to the advanced view, you can see that we've nested these two SimGrep pattern keys under a key named pattern either, which is doing the magic for this behind the scenes. So if we look at that, I have that example here. There's also in our documentation a whole bunch of details about, okay, in the YAML syntax, what are the sorts of operators that are available? And some of them are actually quite interesting. You can combine SimGrep expressions with a regular expression, which is kind of cool. You can look for patterns that are inside other patterns. And my personal favorite is that the outer shell of SimGrep is actually written in Python, which is great for just kind of like generic scripting. So you can actually have a pattern-aware Python and use SimGrep to extract the abstract syntax tree, but then have Python code basically providing arbitrary logic of like, oh, like should we trigger here or not, based off of the variables that we captured using SimGrep. So I think one of the other cool things about SimGrep is that, you know, normally when you grab a linter or a security tool, they are shipping with essentially a lowest common denominator rule set. But a lot of the time, the things that are the most interesting bugs at your organization are things that are super specific to your organization. So here's an example that we've constructed to kind of show this, where we've got a financial trading application. And in this application, you have to call verify transaction on every object before you call make transaction. So this is just like a very basic example of something that is designed to be very business specific, right? It's like, oh yes, nobody would ever ship a linter rule with this kind of problem, but it could be something that is actually highly valuable to detect inside our organization. So here we have a couple of examples. So like on line 16, you can see this is good. We call verify before we call make. Line 22, this is bad. We just call make transaction. Line 27, we call make transaction and then verify transaction. So that's bad. And the rules that we've got here, you can see I'm using the two concepts that I told you about before. So I'm using the ... operator to say, hey, I don't care about what becomes before or what comes after make transaction. I don't care about the arguments to it. I don't care about the arguments to the parent function. I'm abstracting away the method call. And then if you look at the advanced view of this, I'm actually using that method call inside the message that I'm printing out. And then I'm grabbing, you know, I'm triggering on any function that has make transaction inside it, but then I'm filtering out any function that has verify transaction before make transaction. So the reason I'm showing you this example already filled out is because it's not quite done. There's actually a bug in it. Maybe you've realized it already if you are an astute watcher. So if we look at this one, we're not triggering on line 56. And on line 56, inside this function, we've got verify transaction called with other, and then make transaction called with T. So, oh, I think the stream may have switched over on the live stream, guys, because I see it's back to the breakout room. Oh, okay, now it's back. Awesome. And let me know if this is not big enough or like zoomed in on the text. Just let me know. So anyways, if you were following along, like you may have already figured out the solution to this. So I'll give you a second to think about it, but then I'm going to jump into it because we're short on time. So if I jump in here, basically I need to say that, hey, whatever the argument to make transaction is, transaction here, that needs to be the same argument for the argument for verify transaction needs to be the same argument as make transaction. So now I've made my filtering out case a bit more precise. And if I run this, we now successfully trigger as well on line 56, where we called verify transaction with something other than make transaction. So that's pretty cool. The last example I'll show you is totally different. So this has nothing to do with bugs at all. Let's imagine that we wanted to just get a comma separated value file with a list of everything inside our application in terms of the routes that the application has. So I can basically come in here, I can say, hey, like app.router.handlefunc. So this is using Gorilla. Put the route here. replace this with handler. And then this would be my HTTP verb as the method, the last thing. And if I run this, we should trigger on lines 14 through 18, which is pretty cool. And then what I'll do is I'll switch over here and I'll write a message, and I'll just say route, comma, handler, comma, HTTP verb. And you can see the matches that I'm getting out. So if I'm running SimGrep locally, I can pass it a --JSON flag that will give me these as JSON, or I could just use this CSV type output. And I'm basically using SimGrep to just extract information from the structure of the program and convert it to another format. This is cool because so like here's an example application that we at R2C have built. So we use this to do essentially a code inventory. So we basically extract from the application, hey, like what are all of the routes that we have? If there are decorators on the routes, this allows us to look for anomalies like, oh, you know, we required authentication for this one route, but not for this other one. That's kind of weird. And you know, like trigger or send notifications in Slack or other things. Not for every pull request, but maybe for pull requests that are adding or removing routes to the application, kind of changing it in a more semantic way. So I covered pretty much everything you need to know. SimGrep is a pretty simple tool, but getting to all the applications is a bit more complex. So if you're looking for more goodness, there's a tutorial at simgrep.live/learned. The last thing I wanted to talk about is the registry. So if you've been watching this and you've been like, huh, okay, DIY Gosec, that sounds cool, but you know, I don't really have a lot of ideas for like rules to write. We actually have a registry contributed like a couple hundred rules from the community that like a bunch of people have written Go rules for. There are also people who have been writing rules from the community that are like slated to make it into the registry but aren't there yet. So probably the like most well-known person in the Go community has been Damien Griski, who's the author of Go Perf Book, who has just been writing, I don't know, he's probably written like a couple hundred SimGrep patterns at this point, looking for, you know, like just kind of like various smells or interesting things. I see there's a question in the chat about like grep and sed for search and replace. I will show you something about that later on in the presentation. I think we're about to get to it. So real quick, because I promised I would show you how to set up SimGrep inside CI. So here's an example, an Apache project. We're like merging in 20,000 lines of code, and we have SimGrep running in CI. There's some overhead to the CI things, but SimGrep actually runs in about 4 seconds on that amount of code, which is pretty good. And so if you go to the GitHub repository for SimGrep, which you can get by going to simgrep.dev and then clicking on the GitHub thing in the top left, there's a whole integrations doc that talks about all of the integrations that we have set up. So the SimGrep core engine has a bunch of features which are pretty useful. One of the ones that we haven't really had time to talk about is what we would call code equivalences. So for instance, if there's more than one way to do it in the program, like for instance, if you are talking about like, hey, I want to call, like find everything where you're saying, this is a call to dangerous method 1 with a string as the first argument. Let's imagine somebody says like x equals a string, and then they call dangerous with x rather than the string. Well, SimGrep should be able to figure out for you that that's actually the same as just calling it with a string directly. And so the engine actually will do that, and it has a bunch of cool equivalences that are basically saying, hey, like actually, maybe, you know, for your rule that you're writing, the order of x plus y and y plus x doesn't matter. And you can program that into the engine to say, like, yeah, I don't care about the, you know, community, the associative property of addition or whatever is true for this rule. So like, just find all those variations for me. And there are a bunch of other deeper features, like there's some basic typing information already, but we want to do a better job integrating typing information from the AST, as well as deeper analysis features like data flow or local taint tracking. You know, happy to talk more about that if you're familiar with the kind of static analysis world. So, okay, to get to the question in the chat from Bakwun, here's a cool example of using SimGrep to do autofix. So if I click into here, let's imagine that we have a developer who is writing some code. They're using listen and serve. And we happen to know that listen and serve TLS is what we want people to be using inside our application. So, we can't actually perfectly patch this for them, because to do this correctly, you need to have like a server key and some other things set up. But what we can do is get them as close as we possibly can. And then we could just like put up a diff that's like, hey, like you need to fill out these other things. I've gotten you as far as I can with a forward patch. So basically what this would look like is we're going to find this in the code. Rather than saying port 80 and nil as the handler, we're going to extract those away. So we're going to say like adder and handler. And then I'm going to want to say http.listen and serve TLS is my fix. The arguments for that have the address as the first thing, then they have a cert file and a key file and a handler. So I just know this, but you can pull up the documentation if you want to see exactly like where these variable names come from. They just come from the arguments to listen and serve inside the documentation. So the cool thing here is I'm using the exact same syntax for the autofix that I was using for the code. And now if I run this, we should see, hey, like we've got this message, found an HTTP server without TLS, use HTTP listen and serve TLS instead, and we're linking to the Golang documentation. And I can just click apply fix, and you can see it successfully moved nil to be the last argument. It kept :80 as the first argument. So that's super cool. Behind the scenes, here is like us specifying that message and us specifying that fix inside the YAML file. So this is really cool to be able to set up inside CI. And actually, we just got an editor extension in beta. So you can actually set this up in the editor, which I think is ideal because if you're going to set up some sort of linter rule like this, the earlier you can complain about it and actually educate like the other person on your team who might not know what is your way of doing things, the better. And then the last feature I'll show you is one that you might have kind of seen in the UI, and maybe if you were following along, you've already done. So coming back to our very first example, wouldn't it be cool if like rather than having to do all the copy and pasting, we could have just highlighted the code here and asked SimGrep to automatically suggest some variations and patterns that would match this example. So in fact, we can do exactly this. So this was actually, believe it or not, an intern project at my company that a really, really talented intern from CMU built. She did a fantastic job. So you can see I just took one of those examples, and now when I run it, I have generalized from line 12 to lines 12, 13, and 15. So that's pretty cool. Please go forth and be dangerous. File feedback. We're very responsive on Slack, and we're really responsive to GitHub issues. This is an active open source project, and it lives and dies through the feedback of users. So if you want to get started right away, you can just brew or pip install SimGrep. There's a default R2C config that you can run on some local code, or I would highly recommend going around and playing with the live editor. If you thought this presentation was pretty decent, or it could be better, that's because of the feedback of prior people who have listened to me chat. So I would love it if you could go to r2c.dev and fill out a survey just to give feedback and help make the presentation better for the next meetup. But yeah, thank you so much for your time. I really wish I could have been in Singapore in person, maybe next year. So appreciate it. And if you have more questions on the live stream, just let me know.
All right. Thank you, Isaac. Thank you. Thanks.
Absolutely.
Yeah. Any other questions? I'm just looking at it. No. All right. Okay. Thank you, Isaac. Thanks for your time. I know it's very late, very early for you. Yeah.
It's either late or early, depending on a morning person or not. So.
Yeah. Hopefully in Singapore soon. Yeah. Okay. Thank you, Isaac. Thank you.
Absolutely.
All right, guys. With that, I think we'll move on to the short segment of breakout room. We have the speakers in one of the rooms, and feel free to join the two links you see on the YouTube channel. And we will chat there for 20 minutes, and then we'll come back for the second talk. All right, see you guys in the room. Hi, hi everyone, welcome back. Thanks to those who
Hello.
joined the room. Hope you had a good chat with the speakers. Right. So without further ado, I think we can start the second talk. Thanks for staying throughout. Over to you, Sweden.
Hey, sorry, Steven, can you unmute yourself? Sorry, Steven. I think you're okay.
Okay, got it. So Stanley, you can hear me now? Good. So two things, open policy agent and its policy language, and also introduce some Go language features. So here is a very typical Go program asking for permission. So let's say we want to buy a flat from the Housing Development Board. This, of course, is not the real Housing Development Board. Here's where the application asks for permission. And the decision is printed there. So the module checking for permission is the policy. So there's a lot of if then else logic there. Anyway, this is a completely valid Go program, and I'm going to run my presentation. So let's run the presentation. Yeah, not the real HDB, and of course, because I didn't write any code, there's no output. So the challenge with asking for permission is that complex if then else logic. This is the real Housing Development Board policy, just a little bit of it for buying a flat in Singapore. You need to have at least one Singapore citizen, at least one other Singapore or permanent resident, and lots of other conditions. So the challenge now is writing that really complicated if then else statement. But before that, how do policy checking systems work? There's the input, there's the system, and there's the output. The input is typically in some sort of JSON or YAML or CSV file. And the system needs to convert that input into some internal data structure. And that's what I was talking about. This whole series of if then else statements to determine whether it is okay or not okay to proceed with a request. So at least one Singapore citizen, quite easy to scan, no problem. The if then else statement I can understand. How about this if then else statement? It gets a bit more complicated. Enter Open Policy Agent or OPA. They created their own language to handle all these if then else statements. So a traditional if then else statement in a typical programming language would be if method is get and URL is not secret, okay. Or if method is post and the URL is new customer, also okay, return allow. Otherwise, return not allowed. Rego if then else statement is a bit different, and it took me some time to understand, but they had good reasons to create a new language. The first line is pretty easy to understand. Default allow equals false. If you don't do anything, allow is false. Here is what is called a Rego rule. This is a allow is a Rego rule, which returns true, that blank defaults to true if there's nothing there, if method is get and URL is not secret. So there's an implicit and here, and there's an implicit true here. This space here is an implicit or. or allow is true if method is post and URL is new customer. So why did they do this? This makes it a lot easier to write rules, which we'll see later, from policy documents. I mean, real world policy documents like you find in a PDF file. Here is another example of an OPA rule. Not only can it return a Boolean, true or false, it can return a string, number, or JSON object, or array. So here, grant is an OPA rule, which returns this JSON object if income is less than 10. Or the OPA rule grant will return this JSON object if income is less than 5. Or the grant rule will return this JSON object if income is greater than 10, greater than or equal to 10. So how do we define our rules? Well, the rules have to live, like Go, have to live in a package. And I've named this package Housing Development Board, HDB. Here's a rule. Default, at least one citizen is false if I don't do anything. And the at least one citizen rule will apply true if input applicants underscore, we'll talk about that. But basically how you read this line is, if within the input you find some applicant where the applicant residence status is citizen, at least one citizen returns true. Now here is my data file. My data file is my HDB application.yaml. It has 3 entries. First is a PR, second is a citizen, and the third other. So let's run this. It's in an example directory. And I'll copy this command line and I'll talk about it after we run this thing. Scan example. And when we run that, it says at least one citizen is true. Yes, of course, we saw in the data, there was one citizen there. So explaining what we just did. So OPA assigns the YAML document you just saw to a global internal variable called input. And policy files like Rego files, data connections to external databases, these are assigned to an internal global variable named data. So when I typed in that command string, input this YAML file, data, this policy file, format just says pretty print the format. But here's the important part, data HDB. That is my query. What that query says is, please tell me everything you know about data HDB. Data HDB, there's a rule there. Please tell me everything you know about this rule. And in that case, the rule turned out to be true because there was at least one citizen. So, like I mentioned, all policies belong to a package, but there can be a hierarchy of packages. Let's say you want to collect keys for your new flat. You can have package hdb.newflat.keys. So, like I mentioned, that query data HDB means tell me about the policy decisions made in the HDB package. That was the output. So what's the meaning of this underscore in here? It basically, as I mentioned, it scans the input if there is at least some applicant where that applicant has a residence status of citizen. This rule is true. Pretty neat. I like it. But if that was all it could do, it's not very effective. Anyway, this just presents that the citizen goes through 1, 2, 3, found a citizen, it's done. If that was all it could do, OPA wouldn't be a very powerful language. Here is where the real power comes in. This line, you now know. If you don't do anything, at least 2 citizens or a citizen and a PR that rule is false. Here, I can say for some I and j, some index value I and some index value j, if I find applicant I to be a citizen and applicant j to be a citizen, implicit and here, and I is not equal to j, then this rule will be true. Or if I can find some applicant I who's a PR and some applicant j who's a citizen and I is not equal to j, then this is true. Now you see the power of the Rego language in OPA. You can write very, very complex policies with these kind of structures. And I'm just scratching the surface here. So like in any good programming practice, we need to test. So how do we test policy? Obviously, when you're dealing with people's lives, HDB flat and all that, you need to make sure that you make good policy decisions. So a test by convention is prefixed by the keyword test, but it's convention. It's not a keyword. It's just a convention. So this is exactly like a rule. This rule is a big rule. It starts from here and ends here, and it has 3 parts with implicit and between them. So it's exactly like a rule except with a with keyword, with input as. So I'm providing the input directly to the test in this JSON structure. So I'm providing this JSON structure directly to this test. So here I've got 2 applicants in the JSON structure. I've got 2 citizens, true. I've got a citizen and a PR, true. Other and a PR, false. But I prefix it with not. So not false is true. True and not false, the test will pass. So let's run this test. It's called toExample. So OPA tests everything in this folder, give me verbose output. And basically it says, pass. Yeah, because we had 2 citizens and a PR. No problem there. Let's change the test fixture to purposely cause a failure. And it says, change the test fixture from, okay, so citizen to citizen other. Well, I think it's not quite right, but let's see. So at least 2 citizens and a PR. So let's change the PR to other here. So this will fail. Save. Rerun the test. And indeed, it fails. It tells you exactly where it failed. Cool. Nice. I like testing code. So how do you deploy OPA? Open Policy Gen, or OPA, can be deployed as a standalone binary because it's written in Go. And that's how I've been running OPA in this talk so far. You can deploy it in a sidecar container, as in a Kubernetes pod, or in a standalone Docker container in some containerized environment. And here is the superpower. It can be a library linked into a Go program. Now, the usual way to interact with OPA is via HTTP JSON calls. You make calls to this OPA process, and OPA responds over the network to you. But if you link it to the library, you don't have to rely on the network. So, self-contained policy checking with Go. That's part 2 of my talk. So, like I mentioned, furthermore, if you want to extend, create functions within OPA itself, you can write OPA functions in Go, obviously because OPA is written in Go. And it can be integrated with a Go application and deployed as a single binary with no external dependencies. My favorite feature of Go. So here is the bi-flat application again, but now a little bit more fleshed out. Here we now have real data structures where the application decision is approved, true or false. And here is my application to buy a flat. It has a PR and a citizen and one other. And here is the code. Now you will understand this code because it looks very familiar. First, we create a new Rego object called RG. And within the Rego object, we have package HDB. We have seen that before. Default at least one citizen. We're talking about one citizen only. False. Input applicants, if there's some applicant where the resident status is citizen, true. Here's where we evaluate the policy. If there's an error in Go, print it out. And we declare a variable called application decision and return whether it's approved or not. So let's run the code. I like running code. It's called term2, go run main. Application result approved true. Let's make sure we trigger a non-approval here. So there must be at least one citizen. Change this to PR. Approve false. We need to have at least one citizen. So explain Go interface, empty interface, and type assertions. Let's look at the code now. OPA is written in Go, but policies can be anything. Some manager thinks up some policy, some politician thinks up some policy. They can write it down in a PDF file or wiki, and this policy can be anything in the world. And Go is strongly statically typed. How do you reconcile these two? Well, when you evaluate the policy, it returns a result set. And the result sets contains expressions and bindings. Expressions are these things, the rules, and bindings are variable bindings, which we didn't really talk about in this talk. But anyway, the first expression, index 0, look for expression 0, the first expression. It has a value. This value, because of the flexibility of OPA, can be anything. In order to make it type safe, I need to tell Go what I expect. What I expect there is a map of string to anything. This anything is called the empty interface. So because I made the value a map of string to something or anything, I can now specify the key, at least one citizen. So I'm pulling out this rule. And when I pull out that rule, that content of that rule will evaluate to true or false. But I said anything. So I need to typecast it or type assert it to a Boolean. Why Boolean? Because application decision, the approved field is a Boolean. So in this case, I have two type assertions, two of them. The first, map of string to anything, and the second, after evaluating its value, type assert it to a Boolean. So Go is really cool. You now have a type-safe application. Let's build a statically linked file. Thing which I was telling you about. Really cool. no external dependencies. So C go enable go build builds the perm2 file. File perm2 tells me it's an ELF64 Linux executable. Where is it Linux? It didn't say, but statically linked. And the size is 15 megabytes. So for the price of a 15 megabyte binary, I've got the whole of the OPA policy engine in my binary. Really nice. But here's even better. That executable runs on Linux. This executable runs on Windows. And it's even slightly smaller. So with the same source code, I can create a Windows binary. How about Mac? Go to list. These are all the targets Go can target. AIX, Android, Darwin is Mac. I don't know what Dragonfly is. FreeBSD, WebAssembly, whole bunch of Linux flavors, NetBSD, OpenBSD, Plan 9, Solaris, and Windows. Very, very nice. So I like to tell people Go is Java done right. So as usual, the presentation and source code is available from my GitHub repository. And as a bonus, if you want to learn more about OPA, there's actually a second presentation in there, but I've made a video of that as well. So this is the time if you want to take a screen capture or write down that YouTube link, or later catch up on the video playback, you can visit the other presentation on how to write functions in OPA. So that's all for my talk. Thank you. Teck Chun, back to you. Teck Chun?
Right, sorry, I was on mute.
All right, no worries.
Okay, thank you, Swin. Thanks for the talk. I'm trying to see if there's any questions. There appears to be none.
Good. Well, not good, but it's been a nice talk.
Yeah, do give it a spin for what Swin has shared in his GitHub repo link. Okay. In that case, we've come to the end of today's meetup. Thank you all for staying back. Last reminder, do fill in the feedback form. We have 5 licenses of Golang to give out, courtesy of JetBrains. So we inform the attendees who's got the 5 licenses. And also watch out for the next Go Meetup in September with the regional meetup groups. Okay. And this is the QR code. We'll leave it here for a while. Yeah, and for the September meetup, we do have a mini call for papers. So we are looking for speakers from the community who want to speak. So we will have tuning from around Southeast Asia for the different meetup groups and Golang developers. So we look forward to your call for papers submission. All right, guys. I think that's all from us today. Thank you again to Google Dev Spaces and the support. That's all for tonight, and we'll see you in September. Thank you all. Good night.